Hello, how do we find the magnitude and direction of vectors? Well, magnitude is just a length, and the way that we denote magnitude is we put these two little bars around the vector. That means what's the length of vector v? And to find it, you just use the components of vector v. See, if you know the x component and the y component, you can just use the Pythagorean theorem to figure out the length of that vector. The direction of a vector is its angle. So this angle right here, and the way that we find that angle is we say that the tangent of this theta is equal to y over x. So theta is equal to the inverse tan of y over x. Now it's very important to pay attention to which quadrant you're in because theta should make sense for that quadrant. And we'll see some examples like that. Let's get to it. All right, let's find the magnitude and direction if I have an initial point at 1, 1 and a terminal point at 4, 5. So let's start by finding the components. All right, this has components 3, 4 because we could see that x had to increase by 3, y had to increase by 4. So let's draw that and see which quadrant we would be in. All right, so now I use my components 3 and 4. I can see I'm in quadrant 1. And just using Pythagorean theorem, we can see that the magnitude of this vector, let's give it a name, we'll call it u, is equal to 5, just from the Pythagorean theorem. Now let's find the angle of that vector. So tangent of theta is equal to y over x, so that'd just be 4 over 3. So the theta is equal to the inverse tan of 4 over 3. This tells me that theta is equal to 53.1 degrees. Because I'm in quadrant 1, this angle makes sense because it's between 0 and 90. So this vector with this initial point and this terminal has a magnitude of 5 and a direction of 53.1 degrees. All right, let's find the magnitude and direction of these two vectors that have the components 0, 4 and negative 4, 0. The best thing to do in any of these cases is to draw it first. All right, so I'm also going to give them some names, u and v. So if I draw this 0, 4, I don't need the Pythagorean theorem. I can see that the magnitude of vector u is just that length, 4. And the direction, this angle right here, the direction is 90 degrees. All right, so you try this one. Pause the video, blah, blah, blah. All right, again, we can see that the magnitude is 4, but if you tried to do the inverse tan of 0 over negative 4, you would get 0. But drawing it lets me see that the angle is actually 180 degrees. All right, let's try one more. So if I draw this, negative 5, 12, I end up with a vector that looks something like this. I can use Pythagorean theorem to figure out the magnitude of this vector. And again, I'm sorry, let's just give it another name. We'll call it v. So we'll again use Pythagorean theorem, and this tells me that the magnitude is 13. All right, so now let's figure out the direction, this theta right here. Theta will be equal to the inverse tan of 12 over negative 5. And evaluating that, I get an angle of negative 67.38 degrees. But does this make sense? Right? No, because this negative 67 degrees, that's this angle going in a clockwise direction. Because I'm in the second quadrant, I need an angle between 90 and 180. So what I'm going to do is I'm going to add 180 degrees. Because the angle I'm looking for is this angle. And the only reason I say add versus subtract is because this angle was already negative. So the actual direction of this angle is 112.62 degrees. Which makes sense because I'm in quadrant 2. Just going around the quadrants, you could see that this tan would be negative because you have positive over negative. This tan would be positive, and this would be negative. So if we're in either of these two quadrants, whatever answer you get for your inverse tan, you just want to add 180. And for this quadrant, since it's negative, we're going to add 360, which is really just taking this angle away from 360 since it's already negative. All right, but what if we're given a magnitude and direction and we want to write it in component form? Let's call the length of this vector r. And this r has components x and y. Well, for this theta right here, I know that the cosine of theta is equal to x over r. I know the sine of theta is equal to y over r. So solving for those components, I get x is equal to r cosine theta, and y is equal to r sine theta. So if I'm given a magnitude and direction, the components are just r cosine theta, r sine theta. All right, let's do that given the magnitude of vector b is 8 and the direction is 300 degrees. So I'm just going to take r cosine theta, 8 cosine 300, 8 sine 300. Now 300 degrees is on the unit circle, so I can easily see the cosine of theta and the sine. So I'm just going to take 8 times the cosine of 300 is 1/2, and 8 times the sine of 300, which is negative root 3 over 2. So the component form of this vector would be 4, negative 4 root 3. Now if we didn't have the unit circle, we could just use a calculator for any angle not on the unit circle. But that's how we go from magnitude and direction to component. And that's all. Bye.